Previously, I introduced you a concept called elementary transformations and showed only for one example, which in my opinion is not so sufficient in order to clearly understand how it works. So I decided to show you 4 more examples, 3 of which are kinda exotic ones. So let's start with example 1. Unlike previous system of linear equations, here we have already 4 equations and 4 variables. x2 minus x3 plus 2x4 equals 3, 3x1 minus x2 plus 2x3 plus x4 equals 9, x1 plus x2 minus x4 equals negative 1, and finally minus 2x1 minus 4x2 plus x3 minus x4 equals negative 2. And the task is the same one as previously, to find variables. And let me rename each equation with letters L1, L2, L3 and L4. As I said in previous video, L1 corresponds to equation 1, L2 corresponds to equation 2 and so on. Now we need to pick first variable, in this case x1. And since equation 1 doesn't contain x1 at all, we need to take any equation below which contains x1 and swap with the first equation. I think I'll take third equation because it looks pretty attractive. There you go. Now under first variable, I mean under x1, we need to create zeros using our elementary transformations. So equation 2 contains 3x1. So in order to get 0x1, I need to take equation 1 and multiply it by negative 3 and add it to equation number 2. Equation L3 doesn't contain x1 at all, so we can skip it. And finally, equation 4. We have minus 2x1 and we need to add equation L1 multiplied by 2 in order to get 0x1. After 100 million thousand minutes of calculations, we will get an updated system. x1 plus x2 minus x4 equals negative 1, minus 4x2 plus 2x3 plus 4x4 equals 12, x2 minus x3 plus 2x4 equals 3, minus 2x2 plus x3 minus 3x4 equals negative 4. So because 0 times x1 is equal to just 0, I decided this time not to write 0 times x1. We are done with first variable with x1, so now we can calmly cross out equation which contains x1 mentally. Now we are left only with 3 equations, and here we take first variable, which is x2, and repeat the same process as we did with x1. In first equation you might notice that we can divide both sides by number 2, which is the same as multiply by 1/2, according to linear transformation number 1. Take first variable x2, and under x2 we need to create zeros. We can do like this. Equation L3 is going to be equal to twice equation L3 plus L2, and equation L4 equals L4 plus L2 times negative 1. And once again, we made an update of our system. here minus 2x2 plus x3 plus 2x4 equals 6, then minus x3 plus 6x4 equals 12, and finally 5x4 equals 10. With x2 we are already done, so we can mentally cross out this equation. And we are left only with two equations. And first variable here is x3, and under x3 we must create zeros. But it's already done. So there's only one equation left after mentally crossing first one out. And now it's time to summarize. I mean, rewrite system of those linear equations which I've already crossed out. And as previous, we are starting from the last equation because it contains only one variable and it's easy to solve. Here, x4 equals 2. Now plug x4 into next equation and we will get x3 equals 0. x3 and x4 we are plugging into next equation and we are getting x2 equals -1. And finally, we are plugging x2, x3, x4 into the next equation to get x1, which is equal to 2. And this exact pair of numbers are a solution of our system. Now take a look at the next system of linear equations. Minus y minus 5z equals -3, minus 2x plus 2y minus 6z equals 6, x minus y plus 3z equals 3. So firstly, choose first variable, in this particular case, x. Since first equation doesn't contain x, I need to choose another equation which contains x and swap with the first equation. And under x, under first variable, I need to create zeros. Equation 2 will be rewritten as equation L2 plus twice equation L1. And equation 3 won't be changed since it already contains 0 times x, which is the same as 0. And there you go, we'll have an updated version of the system. X minus y plus 3z equals 3, 0x plus 0y plus 0z equals 12. Wait a second, what the fuck? So we have 0 equals 12? Are you serious? How is it supposed to be? Previously we were using linear transformations and all was kind of legitimately. But this time 0 equals 12 doesn't make any sense at all. So the only conclusion that we can make is that there are no any solutions of this particular system of linear equations. Well, we can't really pick any x, y, z so that 0 could be equal to 12. It's a nonsense. And we are moving on to another example. This is almost the same system of linear equations as on example 2, but this time in third equation instead of equals 3 I wrote equals -3. And here we are doing the same steps. So first of all, I will take equation 1 and 3 and swap them, and then I'll do zeros under variable x. Then I'll get an updated version of the system. X minus y plus 3z equals -3. But this time in equation 2, we'll get 0 equals 0, unlike in previous example when 0 was equal to 12. And finally, third equation minus y minus 5z equals -3. The last equation I wrote for a reason because we haven't done yet. And what does it mean 0 equals 0? Well, it's true. On the left hand side we have 0 and on the right hand side we have 0. So we don't actually care about this equation because it works. So now we are left only with two equations, x minus y plus 3z equals -3 and y minus 5z equals -3. But unlike in previous examples, here we have two equations but three variables. So now we have discovered a new case of solving the system of linear equations when the amount of equations are less than the amount of variables. And turns out that in this particular case, there are going to be infinitely many solutions. Well, okay, infinitely many solutions, but how can we describe a solution in this system? So we must begin with picking up some variables which are going to be free variables. It means that we can pick any number we wish. How many free variables are there? In order to find out, we need to take the amount of variables and subtract the amount of equations. In this particular case, 3 variables minus 2 equations. Only one free variable is going to be. And it's considered to pick a free variable starting from the last variable. So here, a free variable is going to be z. And the rest variables, namely x and y, are going to be dependent on variable z. Now let me draw an up arrow and we start from the last equation to get variable y, which is equal to minus 5z plus 3. And as you can see, variable y depends on variable z. Since z is a free variable, we can take any value we wish, like 0, 1, -2, and so on. Now go to the next equation, and here we must plug into variable y in order to find x. Thus, x is going to be equal to -8z, which is also dependent on z. And there you go, we have a solution. X equals minus 8z, y equals minus 5z plus 3, while z can be any number we want to pick. And the last fatality example is here. 2x1 minus x2 minus x3 minus 3x4 equals 0. x1 plus x2 minus 2x3 is 0. 4x1 minus x2 minus 3x3 minus 5x4 equals 0. It's kinda unusual at first sight, since in last examples we had the same number of variables and the same number of equations. And here, 4 variables and 3 equations. Kind of unusual. But we don't give a damn and do the same process as we did before. Take first variable, x1, and create zeros under x1. Equation 2 will be equal to minus 2 equation 2 plus equation 1, and equation 3 can be equal to equation 3 plus equation 1 times -2. And here we have an update. 2x1 minus x2 minus x3 minus 3x4 equals 0. Minus 3x2 plus 3x3 minus 3x4 equals 0. x2 minus x3 plus x4 equals 0. And first equation can be crossed out. Now take variable x2, and under x2 we create zeros with the same process. And we end up with a new update. Minus 3x2 plus 3x3 minus 3x4 equals 0. 0x2 plus 0x3 plus 0x4 equals 0. Equation 2, which contained x2, can be crossed out, and equation 3, namely 0 equals 0, is always true. So we don't actually care about this equation. And now we write a system of crossed equations. 2x1 minus x2 minus x3 minus 3x4 equals 0. minus 3x2 plus 3x3 minus 3x4 equals 0. We have the same shit as on previous example when we have the amount of equations less than the amount of variables. And as I said before, in this particular case, there might be some free variables. And the amount of free variables is going to be only 2, because we have 4 variables and we're subtracting the amount of equations, 2. So 4 minus 2 equals 2. Now we take free variables starting from the last one. x4 is going to be free one, and x3 is going to be a free one. Sorry for my spelling, it's kind of weird. The rest variables, namely x1, x2, must be dependent on free variables. I mean, dependent on x3 and x4. So we start from the last equation in order to get x2, which is equal to x3 minus x4. Then we go to the next equation. There we plug into this equation x2 in order to find x1. And x1 is going to be equal to x3 plus x4. And as you can see, x1 and x2 both are dependent on x3 and x4, which are free variables. I think that's all for systems of linear equations. And the main question is that why I decided to include this topic. Well, kind of obvious, because this topic is widely used in linear algebra at all when we want to solve some kind of problems. Soon, I think we will cover the next topic called vectors in geometrical sense. Thanks for watching and being patient, and I hope you could, during this video, distinguish two pronunciations between 3 and 3.